Prime factorization involves breaking down a number into its prime number components, which are the prime numbers that multiply together to give us that original number. For example, let's say we have the number 9. 9 is not a prime number, and prime factorization doesn't really work with prime numbers since they're not made up of factors other than themselves and 1. So we're going to start out with a composite number. Here in this case, we're going to use 9. What is the prime factorization of 9? So the way that prime factorization works is we start with the smallest prime number that's not 1, and we see if that number can go evenly into our target number. In our case, 2 does not go evenly into 9. So we're going to go to the next prime number and see if that goes in evenly. And we know that it does. So once we find a number that goes into our original number, we will write down what is the multiple of our prime number that equals the original number. The multiple of 3 that equals 9 is another 3. That second number was also a prime number, but let's consider another scenario that may involve some extra steps. Let's think about 24. Let's start again with 2. Does 2 go into 24? It does. Now what's the multiple of 2 that gives us 24? And that multiple is 12. And this one's a little more interesting because while 2 is a prime number, 12 is not. So what we need to do with prime factorization is that we continue this tree until we reach all prime numbers. So we're going to start the process over and ask ourselves, does 2 go into 12? 2 does go into 12. So we're going to write that here in our tree. Now, what multiple of 2 gives us 12? Well, that will be 6. Again, we're left with a composite number on the right, and so we're going to continue our tree down and ask ourselves the same question. Does 2 go into 6? It does. And what multiple of 2 gives us 6? Well, that will be 3. And 3 is a prime number, so we are done. So these 4 numbers, 2, 2, 2, and 3, are the prime factors of 24. 2 times 2 is 4, times 2 is 8, times 3 is 24. Why is prime factorization important? It comes down to the simple idea of simplifying. We typically use math for problems in engineering and in science, and when the numbers are simplified, the problem becomes easier. For example, say we have 2 different scientists that each were tasked with doing a certain experiment in the lab. Let's say the experiment was how many times a certain medicine was effective at destroying a virus. Now the scientist on the left did 119 experiments, and they were able to determine that this medicine was effective 68 out of 119 times. And then the scientist on the right, they did a few more tests than the first scientist. They did 168. And out of those 168 tests, the scientist on the right noticed that the medicine was successful in 96 out of those 168 cases. Now we may be the head scientist at our lab trying to determine what do these results all mean. These results both simplify to the same ratio. This scenario illustrates the idea that simplification helps us see a problem more clearly. So let's think about a real-world example where prime factorization may help us simplify certain results. So our example is a company that has a single industrial line that manufactures 2 different models of cars. On the left, we have Model A, and on the right, Model B. Model B is a bit more popular at this point, and the demand requires us to make around 210 of these every 2 weeks. And for Model A, it's about 150 every 2 weeks. In our single line, with our current staff and all the current equipment that we have, our factory has the capacity to build about 32 cars a day. So even though we're able to make 32 cars a day, that may not be the optimal number to make. We're not sure yet. Our goal will be to create the same number of cars every day, which will allow our employees to maintain a consistent work schedule and also help us optimize our deliveries, which can help keep costs low. For example, say that our delivery trucks that deliver our vehicles can carry up to 10 cars. It may not be efficient for us to make 32 cars a day if our delivery trucks hold 10, because then we'd have to store 2 a day or send out a delivery truck with only 2 cars. So let's see if we can use prime factorization to figure out the best production schedule to meet our needs. Let's see if we can find similar prime factors of these 2 numbers, 210 and 150. This may help us in determining what that optimum number of cars to produce is. So let's start with 210. What are the prime factors of 210? So does 2 go into 210? It does. It goes in 105 times, I believe. We have our prime number on the left here, and let's continue our tree with our composite number on the right, 105. Now, does 2 go into 105? No, I don't believe it does because 105 is not even. So we're going to have to move up to 3. We're going to write our prime number on the left again, and on the right, we're going to write 35 because 3 times 35 is 105. Does 2 go into 35? It does not, because 35 is not even. Does 3 go into 35? It does not. So let's keep going. What about 5? The next prime number, 5 does go into 35. And what is the multiple of 5 that gives us 35? Well, that is 7. All right, and 7 is a prime number, so we are done. So we've got 2, we've got 3, we've got 5, and we've got 7. Now let's do the same thing with 150. The number of cars we need to make for our Model A. Okay, what are the prime factors of 150? Let's start with 2. Does 2 go into 150? It does, 75 times. Does 2 go into 75? It does not. 75 is not even. What about 3? Does 3 go into 75? It does, 25 times. 3 times 25 is 75. So now we consider the composite number 25. What are its prime factors? Is it 2? No. Is it 3? No. Let's go up to 5. It is 5. 5 is the smallest prime factor of 25, and we will multiply it by itself. We've got 4 prime factors for each of these 2 numbers here. And again, these are the output goals for our different models. This 210 is the 2-week production goal for our Model B. And the 150 is our goal for Model A. So what we're easily able to deduce from looking at these prime factors is that we have these shared groups of factors right here, 2, 3, and 5. And if we multiply those together, it's 30. We can easily simplify these factors into Model A being a collection of factors 30 and 5, and Model B being the collection of factors 30 and 7. And again, I'm getting these from these extra factors that we didn't add to our group. So what this easily tells us is that we can break up our daily production into groups of 30, and let's say every 2 weeks we take 2 days off, 1 day off a week. Well, that leaves us with 12 days every 2 weeks, and we can work 5 of those days on Model A, 7 of those days on Model B, and now we can rely on a consistent production schedule that's going to help our employees and going to help our company save money.